Hey everyone, today I'm just going to go over the basics of binary search given Leetcode problem 704 binary search. Before I get into the Leetcode problem, I'm just going to go over it visually in Microsoft Paint. If you don't need the visual example, you can just fast forward, go right to the Leetcode problem. So let's say you have an array 1 through 10. In binary search, there's three main points. There's the start, middle, and end. You always know the start because you know the start of an array is index 0. You don't necessarily know the middle and end because not necessarily you know the size of an array. For this visual example, we're just going to go over it how we see it. So we know the end is 10 and we know the middle is 5. So in binary search, you always want to guess from the middle point. So let me explain this. Let's say we guess 5 because we don't know the number yet. Let's say that the number we want to guess is 9, right? And we're guessing 5 first. We know that 5 is less than the number we want to guess. So that means we can cross out 1 through 4. That just split our stack of guessing in half. We know that the number we guessed of 5 is less than the number we want to guess. So our starting point from 1 raised to 6. So now we're at 6 through 10, and our new midpoint, because remember, we always want to guess in the middle, is 8. So again, now we have 8. Is 8 less than or greater than the number 9? We know it's less than the number 9. So now all we have is the numbers 9 and 10 left to guess. And again, we do this new starting point. Our starting point is mid plus 1. So that makes our new starting point 9. And our new midpoint, 9 as well. I'll explain this with code. If you're not fully going to understand how the midpoint works yet, don't worry about it. So we found our number, which is 9. That took what? 3 steps? Let me explain this given the opposite end. Let's say our number we were trying to find was 3. We know 5 is greater than the number we're trying to find. And again, you always want to guess the middle of an array of the size of an element. So again, 5 is greater than the number we're trying to find. So we know that the endpoint needs to move to 4, and that 1 can stay where it is. So our new midpoint is 2. We know 2 is less than what we're trying to guess. So we need to move to 3. We found it. 3 is found. It's simple. I know it's a little confusing because you don't see the code behind it. You don't understand how it's moving. But that is why you're always guessing from the middle. And that's why you always have 3 points: the start, the end, and the middle. Let me explain this in code, and I'll go over it visually as well with the code to help explain how the steps are moving. So let's read this Leetcode problem. Given an array of integer nums, which is sorted in ascending order, an integer target, write a function to search target in nums. If the target exists, then return its index. Otherwise, return -1. You must write an algorithm with O log n runtime complexity. So what does this mean? We know that the array is called nums. It's already sorted for us in ascending order, and that the value we're trying to find is in a variable called target. We need to return not the value, but we need to return the index of the value. And if it doesn't exist in the array, we need to return -1. Binary search is already an O log n runtime complexity. If you don't know big O notation, you might want to go over it. It's not too important if you're just trying to learn binary search right now. Tone in on just binary search for now. So for binary search, the array needs to be sorted. If the array is not sorted, you want to run the array name and run the sort method onto it with Python or whatever language you're doing and run the method. For us, it's just .sort and it sorts it. So again, you want 3 points. You want the start, which is always index 0. Start equals 0, because we know index 0 is 1 for our visual example. We don't know what the end of the array is. For example, we can't say index 7 or index 8 because we don't know the size of the array. Thankfully in Python, and very many other languages, there's a method called len. This will get us the last index in the array. So you want to lend the array variable into the method. So len nums 1. So what this does is, let's say this will make n equal to 10. This would be n. It automatically finds it with this method. This is start, because it's index 0, and this is end with a method. And how do we get the midpoint? While start is less than or equal to end, mid is equal to start plus end divided by 2. What does that mean? So start is 0 currently. Don't worry about it for now. Start is 0 currently. So let's say you have the end point of 10. We know that 10 divided by 2 equals 5. So it gets the index of 5, which we know is 4. We can set mid-val equal to nums mid. That's the value of the index. So really, mid is equal to the index of 4, and mid-val would be 5 in this array example. And if you're confused with indexes, hopefully you understand that before doing binary search, but 0, 1, 2, 3, 4. That's why it's index 4, value 5. So if mid-val is equal to target, return mid. Now, why are we doing this? So if the middle value, which is 5 for our visual example, is equal to the computer's target guess, then we don't need to continue. We can return that index because we're not returning the value, we're returning the index for this problem. But that's likely not the case for all the case tests in this problem. So we want to have other scenarios. Else if mid value is greater than or equal to target, and I'll go over this in a second, then we want to lower the end. Mid, subtract 1, else raise the start. So let me explain this. If the value we guessed was too high for the number that the computer actually wanted us to get, then we need to lower our end target. So like I did here, let me show you. So when we guess 5, if 5 was too high, because let's say the computer had 2 that he wanted us to guess, or it wanted us to guess, then we need to lower our end. Our end needs to become 4. Why does it need to become 4? It's because end is mid subtract 1. So the previous mid was 5. So we need to do end equals mid subtract 1. So 4. This is the new end point. It is 4. The start can stay the same because we did not guess too low, we guessed too high. So end equals mid subtract 1. And then the mid will then be updated because mid is always start plus end divided by 2. So the new midpoint will then be 2. And we would guess it in this scenario with this array. That's not the scenario for the Leetcode, but that's the scenario for our visual example. Else, which is the opposite scenario of this, if we guessed too low, for 5, then we would raise our start value. 1 would become 6 because the start is equal to mid plus 1. And then the mid value would then become 8. And remember that with flooring, we're always, if it's an odd value, we're always going to round down. So let's say the value is 5.5, it's going to become 5. If it's 7.5, it's going to become 7. It'll always round down to a floor value. If it doesn't exist, then we need to return -1. Because as it says here, we need to return the index, not the value. So returning mid. And if it doesn't exist, we need to return -1. Now let's run this. We see it passed. Just these 2 case scenarios. Let me submit the full thing so that way we can see it runs all scenarios. Boom, runs just fine. We beat 100% of users with our runtime, 61% with the memory. We see with test case 1, -1, 0, 3, 5, 9, 12 is the array. The target wanted us to find 9. So 0, 1, 2, 3, 4. It was an index 4, and we found it in index 4. As expected, index 4. And in test case 2, we see -1, 0, 3, 5, 9, 12. The computer wanted us to find the value of 2. If you take a look at the nums array, 2 does not exist in this array. So we needed to return -1 because 2 does not exist in this array. Thankfully we did. We returned -1. Expected was -1. We passed. And hopefully this broke it down for you visually to help you understand how this works. I know it can be a little confusing or overwhelming, but it's really simple once you get the hang of it. I recommend just doing this same problem multiple times. Do it once, wait a few days, do it again, wait a week, do it again. If you forget, do it once a day. Spaced repetition is the best way to understand binary searching and the algorithms with it.